Good afternoon, ladies and gentlemen, and welcome back to the Flawless 195 World Tour. I'm Captain Wilson, and this is flight 131 of 218. It is Tehran, Iran to Ashgabat, Turkmenistan. And the departure time is going to be about 2:40 p.m. in the afternoon for a total flight time under an hour, 55 minutes. Should get us up and down there, so we'll be up there, cruise for 20 minutes or so, and then back on down we come. Now, we have got a very interesting scenario weather-wise. This is likely to be the most extreme flight so far on the weather front. We have got a serious weather front over Turkmenistan at the moment. Almost to the point where I was thinking of leaving it for a few days. But I'll try and tackle it. I've got time to sort of divert if I need to, because it's looking bad. Snowstorm settings, basically. So it is currently -2 and heavy snow in Turkmenistan, in Ashgabat. So we're going for it anyway. I was thinking, do we wait a few days? I think if I was in the Himalayas, if it was Bhutan, Nepal, that region of the world, I would hang fire for a few days and let this weather pass. But I'm willing to have a look. Give it a go. If it is too bad, the visibility is impossible and it's mountainous, I'll look at swerving us to a different airport and then going back to Ashgabat on a different day. But we'll have a look. What the situation is as we get over there. But yeah, visibility, this might be as good as it gets because we can see some mountains over there. We've even got a bit of blue sky in that direction. In fact, I think we're flying over that way, actually. So, yeah, looking good. No, I think it's going to be pretty dreadful in terms of weather, looking at the weather radar as I was setting up this flight. But, yeah, 55-minute flight. I'll get some F1 videos on because it's launch season in the world of Formula 1, and that's what I'm into. So we'll be watching some stuff. Audi launched the car yesterday, albeit not the real car. By the looks of things. But anyway, I'm going to watch some stuff on the new Audi reveal and this, that and the other. So we'll get the plane set up now. We'll get up there. But like I say, yeah, it's likely to be heavy snow, so we're going to play it cautiously. We have got ILS in, but it seems to be a bit extreme where we're coming over some mountains, and it might be a similar situation to this flight. Where I sort of go, right, we're coming in over mountains, let's just play it cautious. Once we get over the mountains, then we'll have a look at coming down. So I might not follow the flight plan 100% accurately, but it's about self-preservation and survival out here. So yeah, I am going to play it cautious, but yeah, the weather is not looking good, if I've made that clear. Let's get on with it now. I'll get the plane set up. We are heading, we're heading northeast, I think, for this one. Yeah, we're heading northeast from Tehran to Ashgabat. 55 minutes predicted, and setting off, 2:40 p.m. local time. Okay, let's get on with it. Get safety demo on now. And, welcome to what could be a very sketchy flight 131. Gotta have your wits about you.
Please pay attention to illuminated signs and crew instructions, including the following safety procedures. The safety card found in your seat pocket contains important information about exit routes, oxygen masks, life jackets, and the brace position that you must adopt if you hear brace, brace. There are 8 emergency exits on this aircraft. The cabin crew are now pointing out the exits nearest to you. Please be aware that your nearest usable exit may be behind you. Emergency lighting will guide you to an exit. In an emergency, leave all baggage on board. Your seatbelt is fastened, adjusted, and released as shown. It must be fastened when the seatbelt signs are on, and we recommend that you keep it fastened at all times. If the air supply fails, masks will drop from above you. Pull a mask towards you to start the oxygen. Put the mask over your nose and mouth and breathe normally. Hold the mask in place with the strap. Pull on each side to adjust. Put on your own mask before helping others. If we land on water, take a life jacket from under your seat. Remove from the pouch and put it over your head. Pass the tapes around your waist and click together. Pull the strap to adjust. Do not inflate it inside the aircraft. When outside, inflate it by pulling the toggle. If it fails to inflate or needs topping up, blow into this tube. There is a light and whistle for attracting attention. The cabin crew can assist you with life jackets for children. Your tray table must now be stowed, armrests down, window blinds open, and seatbelt fastened. Further information regarding your safety on board can be found in the in-flight magazine. We hope you have a great flight.
Cabin crew seats for takeoff.
Audi's officially launched its new F1 team, but the real car's being kept hidden and remains a mystery, even though it's already run on track. The Audi R26 completed an early shakedown at Barcelona nearly 2 weeks ago, when grainy images and video of it emerged as some tried to capture it from a distance outside the circuit perimeter. But the real thing remains in the shadows, as its team season livery launch event in Munich on Tuesday night was mainly about showing off its new colour scheme and full range of partners. That livery is basically the 1930s Auto Union meets modern day titanium concept car shown towards the end of last year, and may well be divisive among fans, although in our experience it at least looks better from some angles than others, and better in reality than on camera. Beyond that, Audi, where's your car? It made a big effort to be the very first team to run on track when it completed a shakedown at Barcelona on January the 9th. There wasn't much material released from the day, just a few teaser images afterwards, which was fair enough as that wasn't really the point. And Audi did always tee this launch event up as a team launch, not something for the real car. Still, we can't help wonder why. Audi entering F1 is a big deal, its new car is ready, and it's playing down expectations massively for 2026 anyway, so why not show the car off? That's better than basically holding 2 livery launches, given this is just October's event with more stickers on the car. Maybe it's because the real car is a little basic and, dare we say, slightly underwhelming in its provisional specification. But it means the only real Audi insight we have is from that distantly shot shakedown, which revealed little. We're pretty sure the car's got push rod front and rear suspension, it's an early iteration design with very basic aerodynamic features, and it didn't run as much as it should have. Those filming days permit up to 200 kilometers of running, but Audi only managed about a quarter of that. Team principal Jonathan Wheatley has said the big difference to the 2025 Sauber is that Audi's new car looks like one from front to back that's been designed with one purpose, an allusion to the integration and packaging benefits of being a full works team. But it would be lovely to see that design from front to back. If you have seen or heard what did emerge from the shakedown though, you might have thought that sounds like an improvement, and Wheatley agrees. Having obviously heard the new car in person and kept an eye and ear on a couple of other teams on Instagram, he reckons the new engines with increased electrical power output but no MGUH sound more aggressive than before. The bigger point from Audi's perspective is that it got a car ready so early to test 9 days into January, even if it won't show us what that car looks like. And Wheatley said the reward for a hugely ambitious undertaking is it got us ahead of the game, with new Team Cadillac running a week later and Racing Bull shaking its car down on the same day as Audi's launch event. Nobody else has hit the track so far. To make that possible, Audi completed its fire up at the factory in mid-December, a month before reigning world champion McLaren did the same for its car, for example. This all matched a timeline Audi head of F1 project Mattia Binotto had mapped out back in early November to us, and it doesn't happen without being in the plan for a long time. Technical director James Key revealed that the January shakedown plan was first set out internally 18 months ago. Still, it didn't come without challenges. The final stressful phase of testing the engine on the dyno and building up the car in November last year, for example, came at the time the factory also had to deal with a massive 2025 car rebuild due to Gabriel Bortoletto's huge crash at the Brazilian Grand Prix. And returning to the point about Audi having a simple car to start with, it's clearly been more conservative in some areas. That's got to be the case to get a car ready to run so early in the year. The aero specification is basically one that Audi was happy to have on just for reliability and systems checks, and this will almost certainly be on the car again for the private Barcelona test next week when teams can run on 3 out of 5 days. At one of the 2 Bahrain tests, Audi plans to introduce what it calls its race update, which it will use in the season opener. It hasn't pushed its initial engine and car parts because as a new works team and with a complex engine to figure out, reliability and accumulating mileage as early as possible are key. So when Audi ran at Barcelona the first time, it was primarily about gathering initial data on the new engine rather than chasing any kind of meaningful performance read on the car, even by shakedown standards. There are benefits on the car side too, to make sure there are no nasty surprises once Audi starts running through a more serious program, but for Audi the engine is the biggest unknown. As we mentioned, the team didn't maximise the filming day in terms of the mileage limitation, but Wheatley claims that we achieved what we wanted to achieve in terms of getting both drivers in the car, running through various systems checks, and getting initial feedback. Having developed its first F1 engine, Audi is one of the few works teams on the grid, but it's a newcomer along with Red Bull Ford powertrains up against Mercedes, Ferrari and Honda. it isn't expecting to arrive with a class-leading engine straight away. Audi is worried though that there will be a large disadvantage added on top of its existing inexperience in the form of F1's first real engine controversy of this rules era. That's regarding how the new reduced compression ratio rule should be interpreted for 2026. The regulations specify a 16:1 compression ratio, down from 18:1 previously, measured under static conditions at ambient temperature. Audi, along with manufacturers like Honda and Ferrari, believes that limit should apply at all times. In other words, the compression ratio should never exceed 16:1, even though the engines are capable of running higher than that and would ideally produce more performance by doing so. But there's been a major debate behind the scenes because Mercedes, and to some extent Red Bull Ford powertrains, have interpreted it differently. Their view is that the engine must meet 16:1 at the point of measurement, but can effectively exceed that on track and get more performance as operating temperatures rise and components expand. The gain from that is thought to be worth as much as 0.3 of a second, depending on circuit characteristics, and Audi is strongly against it. Binotto did a good job of sidestepping the topic a few times when probed on it at Audi's launch, claiming he didn't even know if it was true. But eventually, when asked what happens if it is a real trick, he replied, "It is certainly a significant gap in terms of performance and lap time, and certainly that would make a difference when we come to competition." And they don't expect clarity or compromise from a meeting this week when the topic will be raised. It's more for the future, as there's unlikely to be anything done during 2026, even though there is some pressure in some quarters to introduce clarification or an adjustment around the summer break. The more realistic expectation is that any change would come for 2027 at the earliest, and that means any disadvantage Audi believes this interpretation creates on top of any other performance weaknesses that may come from simply being new to F1 engine development is going to be baked in throughout its first season as a works F1 team. As Wheatley said about the main differentiator this season, the engine is going to play perhaps a larger part early on than all of us originally imagined, and I suspect it will be about catching up. There is a huge amount of uncertainty over where the engines, and of course the cars, will actually play out in terms of a pecking order. So if you want to be the first to know the inside track on F1's biggest shake-up in decades, make sure you get your F1 Paddock Pass by joining the Race Members Club. It's the perfect time to check out a 7-day free trial of the Members Club and see the true picture of what's happening in F1. Come behind the scenes with us for exclusive updates, expert analysis, and bonus podcasts just for you. Just head to the Members Club via the link below to claim your 7-day free trial. Audi has already owned the Sauber team for a couple of years, but this is the first F1 car and engine to carry its name. To challenge and beat the likes of McLaren, Red Bull, Mercedes and Ferrari requires major gains to be made on both the chassis and engine sides. An encouraging 2025 boosted Sauber's credibility, taking it from the back into the thick of the midfield fight, but the first Audi year still has modest initial targets. Binotto just wants to finish the first race and the first weekend in total without any significant problems on track. His slightly nebulous goal by the end of the year is to be perceived as a strong and serious competitor for the future by rivals. Then he will feel Audi is on the right path for what it has grandly dubbed Mission 2030, which underlines how long is required to emerge as a true frontrunner. This is at least a realistic timeline. The downside is that it's very much a corporate roadmap of the sort that has more often than not left F1 teams embarrassed when they fail to hit the target. Tellingly, Binotto has phrased things subtly differently. He refers to the objective of being to fight for a championship by 2030 rather than emphatically win one. Binotto's way of putting it is more sensible, as even if you are able to contend for the title, you can never guarantee being able to win it, and you certainly have no divine right to do so. But overall, it reflects the question marks hanging over an engine program that is brand new and a race team that is still evolving in terms of facilities and staff. Sauber only opened what's called the Audi Motorsport Technology Centre in the UK, a key outpost that can house personnel not based in Switzerland or Germany, last summer. And as Wheatley points out, it's still rebuilding after years of financial struggles in the wake of former owner BMW pulling out of F1 at the end of 2009. So improvements are required in all areas. Binotto targeted improving the team's culture when he joined in 2024, something that Wheatley has also contributed to since coming on board in April last year. And he points out that it's only by improving in every single area that Audi can deliver on Mission 2030. While Binotto says the engine infrastructure is all in place, it still needs time to develop the engine. At Hinwil, he pointed to the need to improve its manufacturing capacity to improve speed and quality of parts production, for more space through enlarging its campus, and also the brand new driver-in-loop simulator that's been ordered. But this doesn't make 2026 a write-off. Binotto is very clear that he expects the team to perform under pressure as a key measure of its progress. If Mission 2030 is to be a success, and the history of manufacturers in F1 delivering on their ambitions proves that is a big if, then it demands at least a solid first Audi season as a foundation.
OEMs in all different classes all around the world. Now this video of course comes with my standard disclaimer that no aerodynamicist can perfectly predict all flows by eye, so everything presented in this video is at best an educated guess.
Now the images that have been released are in two batches. You've got these sort of studio shots like this, and then you've also got a series of white background studio shots. Now, if these are renders, they are exceptional ones, because some of the details in here, in terms of how the swan necks are connecting the wings, in terms of the split lines, the tape on the split lines, a whole bunch of other features, are really, really good. And this certainly isn't just one of the F1 show cars. So again, much like the Red Bull, I'm going to analyze it as if this is a real car. Of course, bearing in mind that that spec could change between now and testing and race 1. So starting at the front of the car, we can see a few interesting details on the wing that are different to the Red Bull. Firstly, you'll notice that outside there is no front canard on the outside of that front wing end plate. There's nothing there, nor is there any obvious vertical veins there. Two details that were both on the Red Bull car and not present on this car. Now that may indicate bits that are yet to be fitted, because I would assume that they would probably want to have the ability to control some sort of structures around here, but maybe they'll want to leave them off and just leave that area clean. I would guess though that something is going to sprout out here. Looking at the end plate itself, it's quite a different shape to what I discussed in the Red Bull video. You can see that it's more outwashing around the top, and that naturally brings the top tip a little bit further outboard as well. Now, in this context, like I was talking about in the last video, the high pressure on the top will drive vorticity over the top of the end plate in that direction. Now moving this so that the end plate is sweeping further outwashing is actually depowering the vorticity that comes off the top, and if you outwash lower down, you'll power up the suction surface underneath the front wing. And so what they'll do with this is that they'll weaken this upper structure and they'll move it slightly outboard, which will change how they're managing the upper tire wake and the tire wake further rearwards. This will also interact with their front cake tin scoop, where you can see that on this car, the front cake tin scoop is much higher compared to the Red Bull model, where the cake tin scoop sat much lower down. And where they position this is going to be directly affected by any structures that are getting thrown off the front wing. Moving further inboards, we can see that we have ourselves an active aero actuation pod just here. So that particular pod is what's going to make the wings rotate up and down, so the flaps will rotate around pivot axes through here, and there's a pod on each side to get that job done. Now moving further inboard again, what we can see is that we have a nose where they've really decoupled the structural mounts from the center of the nose. So they've gone and they've had the mount come up, and then it goes, turns 90 degrees and goes into the nose. Now I'm going to guess that a lot of that is to do with trying to clean up any junction losses into the nose and get a good flow along the center line of the nose. It's worth noting that this is actually quite a structurally inefficient way of connecting the front wing to the nose, because ideally you have fairly straight load paths, so you would have a straight strut or maybe even an angled strut, but you wouldn't do a strut where you have to go up and curve. It's just not very good because you have to load this particular section in bending, which means they're doing this for aerodynamic benefit. Looking a bit at what else comes off the back of the front wing, you can see that the center line of the front wing through here is relatively upwashing. It's nothing crazy, but it's upwashing a bit. Obviously, the more you upwash on the front wing, the more load you have on the front wing in general, but anything you upwash here is going to go up and hit the underside of the nose, and that means that airflow has to go and navigate the corner around the nose here. And what you can see that they've done is that they've really smoothed off this section of the nose just through here. This isn't a new detail. We've seen it on some other cars before historically, but basically what this does is that if you imagine that from front on view you have a nose structure that was shaped something like that, and you have an upwashing flow that goes in underneath there like that, that flow has to go up and navigate this corner. If it's got a sharp corner, it will separate off there, or more specifically, because it's a longitudinal flow, it will get some degree of boundary layer buildup and loss in vorticity along this particular region just through here. So when you go through and you round that corner out there, you just smoothen all the flows there, you reduce the losses and the roll up just around here, and that can improve performance downstream because you just have cleaner flow available to you. On this car, much like the Red Bull, you can see that it has a pushrod suspension front, and the reasons here are a little bit different to what I thought could be the case on the Red Bull video, where obviously in this case you don't have the scoop down in this junction here. I hypothesized that the scoop being there may be driving the pushrod there, but maybe there's some other reasons why they want to have the pushrod in this region on this set of rules. We can also see in this shot that T-tray that I was talking about before. So you can see just down here, we've got this region along here, and again it looks like they are utilizing a very large portion of the legality box available to them there. There's also some front daggers visible. We'll go through those in another shot. In some other angles, those dagger geometries become a whole lot clearer. What you can see here is this is the floor daggers coming out here. You can see you've got a whole bunch of daggers, and basically what these are doing is that they are going to be cambered in that direction like that, so that as you have any flows that are coming down around the leading edge of the floor to go down under the floor, they get directed sideways that way. So you get a little bit of pressure on top of the daggers, a little bit of suction underneath, overall sideways outwash of the flow, and this drives a degree of vorticity off the bottom edge of each dagger along there that then goes along the car. And this vorticity will usually merge further downstream, but this produces suction underneath the floor. So you get more power underneath the floor, and you get more outwash and more flows being driven to the outer edge of the floor, where you can then use it with any devices you might have on the outboard edge of that floor. You can see in this shot there's just another angle showing those daggers through there. Now, quite an interesting geometry to talk about on this car is the floorboard just here. Now, what you can see is that they've gone for a far more deliberately outwashing design on the forward elements of it, followed by an upwashing design on the rearwards elements. Now, how do I know that the forward elements are outwashing? Well, let's consider the top view. If we look at the board here, what you can see is that the camber on the board is very much in that direction there. Now, that particular camber shows me that the nose is aligned to accept an oncoming flow from that direction there. That tells me that the flow out here is collapsing inwards, presumably from flows to the outboard of the tire moving inwards, and then it's going to pick that up, turn that around, and outwash it there. So we're going to get pressure over here and suction over here. Now then, further downstream, any outwash that we've generated here will then be acting on these upwashing veins through here that are going to generate that local load while still maintaining pressure in this region here. That pressure is going to go on the top of the foot, give the foot local load and downforce, and also any pressure differential you gain on this foot by increasing the pressure on top, driving more flow around the leading edge and increasing the suction underneath, as well as adding the extraction to increase the suction underneath. Those will all combine together, generate more load on here, and that will propagate down to the floor. You'll also note that this particular car has a barge board stay on it, whereas I didn't see it on the Red Bull geometry. You can see it on both sides there, going across just there and there. Now that particular stay is not looking too tricky in terms of what they've done with trying to upwash or downwash or anything like that. It looks like they've just largely tried to align it to the flow. The barge board itself looks like it must be close to minimum height, although one thing that tells me it's not purely minimum height is that it appears that this particular edge is above this edge here. So if this edge of this upwashing element is shadowing the required surface, then the forward portion must be a little bit taller. So obviously they're trying to raise that forward portion up and give it that tiny bit more power in the upper region. You've got to remember that if this is in fact an outwashing element, you'll be shedding some degree of vorticity off the edge, which is going to travel downstream, and that particular vorticity is going to drive a bulk rotation of the flow that way. So maybe that helps keep the lower wheel wake further out, further rearwards. And again, with anything like this, the position of it can be quite important, where maybe they want to put the position of that a little bit further up, and that helps keep a larger area of the wake outwashed more. The mirrors on this car are pretty vanilla. There's nothing too unusual going on here. This is a design and style we've seen for many years now, and I've described it at length in some of my other analyses. You'll also see down low that the intake style and the forward side pod, there's nothing too crazy going on there either. So again, I just refer you to some of my previous year's analyses if you want more information on how these side pod inlets work. Looking further up, there's some interesting detailing around the halo winglets. We can see that we've got a little bit of a step going on in this region here, and that is presumably to try and cast off multiple structures off that winglet. It feels like quite a strange way of doing it. It's not super discretized, so maybe there's some rules limitation that I've missed as to why they want to do that, and not just give it some very discrete shedding edges where they say go sharp serrations or something like that. But anyway, apart from that, like I've discussed on the Red Bull video and others, we're largely trying to control the cockpit losses with these devices. Moving further rearwards on the engine cover, we have a very downwashing engine cover center, nothing unusual there. We also have that tight tapering coke. Again, both of these features I discussed in the Red Bull video. Looking at the back corner of the floor though, there are a few things going on here. Firstly, you can see that deflector off what appears to be the rear cake tin just there. So there's a little deflector going on there that is reaching forwards to the forwards floor. So maybe that's capturing a little bit of suction that might be getting built up from vorticity along the underside of the floor here where they've got the floor slots, and maybe that suction gives you suction on the cake tin there, which might draw some vorticity around that and allow you to control the tire squirt down low and the lower wake a little bit better. But in order to do that, you need to have an effectively working floor corner, and the solution to the floor corner on this car is a little bit different to the Red Bull that we saw earlier. You'll see that on this car, instead of it being a series of slots that are going like this, instead it is a series of longitudinal slots that then turn like L daggers like that. Now, why would you go longitudinal instead of going sort of more lateral to the car? Well, these longitudinal slots typically are a little bit more powerful in terms of the amount of vorticity that they generate. If you have a big open longitudinal slot like this, your vortex will be stronger compared to the other style. It generally speaking just won't be as clean, and that's for two reasons. One, because you're making it so much stronger, you're building up a lot of power that naturally puts a lot of loss into the vortex. The other reason is that you aren't going to effectively bleed as much clean mass flow from straight ahead as when you have slats going across the car where it's just grabbing that clean mass flow and driving it down. So this to me is an approach that indicates they want to really try and power up that vorticity under the floor, really power up what's coming through that floor corner, and that probably interacts with their lower deflector. In this shot you can also see that there's a bit of interesting taper on the bodywork here. You can see that that upper bit of bodywork tapers in quite harshly in the mid portion of the bodywork. I'll just show you that from another angle. You can see that it's this bit just through here is tapering in quite aggressively through there. It's going to be interesting to see how these areas evolve and how every team plays this, because I imagine there's going to be a little bit of variety in there, because you've got to balance how much you're getting your clean flow from the top down to the floor and how much you're getting your flows from the side down to the floor, as well as how you're managing your pressurization in terms of keeping the front wake outboard. Because obviously if we drag in that front wake too early by tapering the bodywork too early, we're going to suck it into this diffuser corner. Finally, moving all the way to the back, let's just talk about the rear wing. Now the rear wing end plate is an interesting one because it's an even more extreme interpretation of what I spoke about in the last video about basically having no notch at the end of the rear wing. My hypothesis behind that is that the rear wing efficiency is a bit less important, so this is just the best way to power up the rear wing with the current active aero system where you can deploy all the time. So that's what I think is going on there, but it'll be interesting to see if anyone goes with a different style of notch in this region. The other thing that's really interesting to note is just how thin the first element of the rear wing is. It looks super thin and super flat. You can see there's very little thickness to that first element, and you can see on the top there's very little camber. It's borderline a flat plate on the top, and it doesn't look like there's going to be a whole lot of curvature underneath either. And again, I would imagine that this is hugely based around maximizing that active aero delta, trying to really minimize the drag when you're going in a straight line, when that active aero system is open. This one doesn't have quite as an extreme an interpretation of the chord length of the first element versus the last two as what we saw in the Red Bull. All three of them all look like they're fairly thin and fairly low in camber, so they're probably doing the same sort of trick in terms of compensating for a very peaky alignment on the first element by trying to have the split here to basically deal with it so that when the wings closed everything stays attached, but when the wings open you have minimal drag on the elements themselves. But when you have a look from the top down, you can see that even though the bias is to the first element, it's a little bit bigger on second and third element than that Red Bull one that we saw earlier. And that is my analysis of the VCARB 03.
Well, that's all for this analysis video. If you liked it, don't forget to hit that like button and subscribe to the channel, as well as turning notifications to on so that you get
Okay, quick update from the flight decks. Right, we just started our descent, obviously. Now, I have just programmed the plane to go down to 7. Sorry, like a normal descent. Now, I am slightly worried about this section of the descent here. This is looking mounted, especially on the right-hand side, but maybe we're sort of going through a bit of a gap there. Let me just zoom in a little bit. Yeah, I am worried about this section of the descent here, whether we're too low. Hopefully we get some visibility. Hopefully we can punch through this cloud and get underneath it. I'm hoping it's not thick cloud all the way to the ground from here. Yeah, I am worried about this section. Because we might be at about 7,000 feet here, and that's looking a bit dodgy. So once we get to about here, I'm gonna have a look and see what we can see. If I can't see anything, I might just level out. I might level out at this point here if I can't see anything, just for the sake of being cautious with it. Because I don't fancy flying blind here at like 7,000 feet. Yeah, I don't fancy that at all. So let's just have a look. If I get to here and I can't see anything, mind you, it might not be. It might be more like, looking at that now, we're coming in. We're at 31 now. It might be more like 20,000 feet here or 18. I don't know. I'm gonna play this by ear. Hopefully we get some visibility. Hopefully we get through this first layer of cloud and we can see what we're dealing with. If we can't see what we're dealing with, I might level it out here, get over that, and then once we get to here, which is pretty much sea level, then we can even deviate, come out to there, lose the altitude, and then come in like that. So yeah, let's have a look here. Let's have a look. See what kind of visibility we get in the next few minutes. Actually, looking at it again now, we're going off flight plan, so we might be coming over this here again. I'm not liking if we're coming over that there, and we're like under 15,000 feet. Yeah, I'm not really liking that. I might actually go for a deviation over here. I might level out in a couple of minutes and go for a deviation over there. Head for there, and then go in like that. Do the turn here and come in like this. Because I don't fancy going over this section there. Completely blind. Let's just see how this plays out visibility wise in the next couple of minutes. Yeah, not liking this. Let's see. I'm better to be cautious than hit the side of a mountain in this thick cloud, obviously. Give it another couple of minutes, but I might, if we get to here and I can't see anything, I might just go like that, and level out and just go fly manually around like that. It's not looking great, is it? It's not looking good, is it? Really? It's a bit risky, this. Do we risk it? Oh my god. I mean, it's not a dark brown, is it? It's not like... It's not a serious mountain, is it? What we at, 20,000 feet? Oh god. Oh god, I cannot see P. Oh my god. Okay, what can we see? What can we see? What can we see? We're way above, aren't we? Oh my god, look at the state of this. It's right dead ahead of us. We're way above, aren't we? Yeah. We're way above any... Oh, thank god we've got this pocket of visibility here. Right, we've got this pocket of visibility. Look at the state of this. But we're way above, yeah. We're going over the highest point now, which is basically this. Yeah, we're way above. Yeah, no, we're absolutely fine. We're fine. And then it starts flattening out. I mean, we're going through some horrendous... Look at the state of this. But there, yeah, we're literally going over the highest point now, so yeah, we're way above it. Thank God, yeah, no, we're absolutely fine. Look at this wall. Look at this wall of God. At least we know it's pretty flat now. Thank God for this little pocket of visibility, because if it was in thick cloud now, I'd be like eyes shut praying. But no, we're clear it easily. Right, so now we've just got to punch into this. It is going to be a VFR map landing. It's not going to be much visibility, is there? Unless we get really lucky. Yeah, I think we're going to be relying on VFR map here. We have got ILS as well. That's going to really help. But if we have to do a go around, if we have to go to UTAA, if it's really bad. I mean, I don't know how long this runway is here, UT1G, but if I have to go around, I can do. Wow, look at this. The end of the world approaches. Look at that for a screenshot. Jesus. This might be the last time we can see the ground until we're over the runway. Wow, look at the state of this. Right, let's punch in. Oh my God. Doomsday. Right. Okay. Right, here we go. Into the fold once more. Say it would be extreme weather-wise. Okay. Not gonna hit anything. Wow, visually, this is as extreme as it's been. Look at when we're in these dark clouds. Oh my God. Wow, we should be banking right now. Yeah, here we go. We should be banking steeper than this, though. Come on, we need to get it turned. Jeez, look at this. Thank God it's flat underneath us now. If it was mountains underneath us now, I would be panicking. I'd be thinking, sod this. Back to Iran we go. But it's flat now. It's virtually sea level below us, so. Right, let's come down at 3. We need to get back on the flight plan. need to keep an eye on interior view as well, because we get a true altitude reading on the 2,500 feet that appears here. So if we go under 2,500 feet, because this might not be accurate, this 6,400 might not be accurate, but if we go under 2,500, it comes up here. So I need to keep an eye on interior view, really, just in case it's massively out in terms of altitude. I don't expect it to be crazy. I think I'll call it a day music-wise. I think we'll call it a day music-wise, for obvious reasons. Right. Oh my God. Wow. Right, we're coming down, we're coming down. I'm going to get the speed down as well. Let's zoom in on here. Let's get the speed down. Okay. Can see the runway there on the map. Right, let's get the speed down. What's ILS saying? Yeah, speed down. Oh, 2,000, right, we're under 2,500 feet now. Right, let's get down to landing speed. Oh my God, this is not your standard run-of-the-mill flight, is it? This is not your standard run-of-the-mill. Oh my God. We've got ILS, that's the one positive here. We've got ILS will guide us in. Just going to grab the glide slope now. Oh, I can't see a thing, mate. Right, we've got to get the flaps out as well. Right. Okay. Glide slope is on. Let's go flaps 1. Oh, can we see the ground there? Landing gear out. Come on, let's have a look at the runway. Oh my God, this is not your bog standard landing, is it? Thank God we've got ILS. Right, can we see? What can we see? Nothing yet. It's okay. Flaps 3. Come on, come on, come on, come on, come on. Can't see anything yet. But we are ready to land. We're at full flaps, 1,400 feet off the ground. Oh my God. I can't see a beam. I'm not going to switch autopilot off until the last... I see I'd normally be switching autopilot off now, but I'm not going to do that. I'm going to get as close to the ground as possible. Can't see anything yet. It doesn't even look like we're descending, it just looks like we're cruising, but we are descending. We're under 1,000 feet now. $800. There it is. I can see the light. I can see the light. Oh my God. Right, should we get autopilot off now then? Right, autopilot off. Okay. See the other runway over there? Yeah, it's a double runway set up. Right, here we go. Look at this, visibility-wise. ILS is absolutely... Without ILS, this would not have been possible. It would have been extremely difficult. As it is, we've got the stabilizers in all the way. Yeah, without ILS, this would have been near impossible. But look at this. No wind. You are joking. Oh, it's incredible. ILS is absolutely saved us there. And it is snow. Look at the visibility. Wow, we are down safely. Thanks only to ILS guiding us in there. That was... If I'd have had to do my own, if I'd have had to just raw dog that with just VFR map, that would have been extremely risky. It would have been extremely nerve-wracking. Wow, look at the weather. This is the worst weather on the tour. As I said it would be. As I said it would be. -2 degrees, but welcome to Ashgabat Airport, Turkmenistan. Local time, 3 minutes past 5 in the afternoon. Wow, you can just about see some remnants of where the sun is there, but wow, look at the visibility right in the middle of a snowstorm. Right, where we're parking her up, son. What's this? We've got tunnels to nowhere. Well, you just walk in and then just drop out the other side. Where are we parking her up? Let's. So they've rendered in all these tunnels and not the terminal. Connected to nothing, so yeah. You just walk down and just drop out the end like a lemming. Right, okay, this'll do us. This'll do us. Oh dear me. What a shocker. They haven't built the terminal that these connect to yet then, or what? But we are down. Wow. That was actually pretty much bang on in terms of altitude and speed and everything. I nailed it. And with this kind of visibility, to have that kind of a drama-free flight with this kind of weather is, well, pretty impressive if I don't say so myself. There we are then. Down on the ground in Ashgabat. How long did it take us, ladies and gentlemen? I said 55 minutes. Why not? Why not? We didn't do any deviations, did we? Why not 55? 51! There you go. 3 minutes and 13 seconds early. There you go. 51 minutes and 47 seconds from Tehran to Ashgabat through the snowstorm. Over a less extreme mountain range, shall we say. I was a bit worried, but in the end we were way high enough. And yeah, the ILS there is what saved us, because if I had to do that free ball in it with no visibility, it would have been a different kind of stress level. But as it was, the ILS guided us in beautifully, and all I had to do was sit her down on the tarmac. And yeah, drama-free, unbelievably. Stress-free, near enough. But yeah, we are down the ground safely. This has been flight 131 of 218. It's been Tehran, Iran to Ashgabat, Turkmenistan. Join me next time where we'll be flying to the capital of Afghanistan. We'll be going to Kabul for the next one. I'm not sure in which direction, although I'm pretty sure we're not heading back west again. Whether it's north, south or east, I'm not quite sure. But we are heading for flight 132 for Kabul, Afghanistan. Do join me for that one. Probably going to be Friday for that one. But yeah, do join me for that. I've been Captain Wilson. This has been an unbelievable snowstorm, yet drama-free flight 131 to Turkmenistan. Thank you for joining. Please do drop me a like. If you are new to the channel, please do watch the route explainer video, and you will get a grasp of what we're doing, where we're going, why we're doing it. Other than that, the world tour continues. Come what may, they can throw whatever weather they want at us, and the world tour perseveres and continues. Thank you. Bye for now. See you next time. There's nothing that can stop us, baby. Nothing can stop us.